discussion, I'm just going to introduce our panelists. We have Molly Chan, who I've worked with on the Providence Bridge, also worked with Gustav on that bridge, but Molly was instrumental in helping Inform Studio deliver that project. She's a designer and community organizer based in New York. And since graduating with a B.Arch degree from Cal Poly, she has been working at Situ, a Brooklyn-based unconventional architecture practice. Her role as an associate project manager for Situ Fabrication involves leveraging Grasshopper to streamline and automate certain fabrication processes. Thanks for joining us, Molly. And then Carl, who's one of my favorite people to talk to, is an architect at the forefront of digital design. He's the Dean of the College of Architecture and Design at Lawrence Technological University. His architectural practice, DOB, that's Design, Architecture, Urbanism, and Building, focuses on expanding the relationship between design and technology, particularly between digital, robotic, fabrication, and building. He's a fellow of the American Academy in Rome, and between 2010 and 2014, Carl was the VP of Design and Creative Director for Blue Homes, where he led a multidisciplinary team that developed green prefab houses that folded for shipping across North America. Welcome, guys. To start off, you all, really started with architecture, but have been in some way closely related to engineering and manufacturing. How has the knowledge of computational design methodologies, how has that knowledge shaped your career? And if you could reflect back to your architecture education, what would you change? I'll kick off with Molly.
Sure. Thanks, Zuby, and thank you, Code D, for having me. Yeah, I mean, I guess I'm assuming I'm the closest to my architectural education here out of the panelists, and so for me, I suppose you could say it was a really natural segue to have computational design knowledge as part of my curriculum. Digital fabrication has been increasing, and classes on digital fabrication have been increasing a lot across different schools. And so as a student, I also worked in the digital fabrication lab at Cal Poly, which led very nicely to the role that I have now at Situ Fabrication. And yeah, I use a lot of Grasshopper in my sort of day-to-day there. So I'm not sure if that really answers the question, because for me, it was just very natural. There are more and more students now who do know Grasshopper when they come out of school. And so it just seems to be the next step in the industry.
Thanks. Gustav?
Yeah, Molly, well, I can only speak for myself, but you do make a fairly good age assessment there. So when I started, my school at the time was in a internal battle for whether we should draw with pencils or with AutoCAD. so that was the big sort of ideological kind of battle then. And there was also an influx of early BIM, in this case ArchiCAD. If you ever use that, it's not very big here in the US, it's fairly big in Europe where I'm from. And to me, that just made total sense. Like, why would you draw pictures of things when you can just like model the thing? I asked myself. And then I went and modeled all of the things and made like really horrible models of horrible projects that had, no concept, but like, deadbolts on the doors, right? And so that's a mistake that many people have, I think, done when you have sort of unprocessed interest in detail in your head. But it persisted with me into, once someone showed me the precursor to visual programming, Grasshopper, which is called generative components, which was done by Bentley Systems. I was again like, this makes so much sense. I'm going to do this now. And before I knew it, I was like getting really nerdy about it. And then in my particular case, so as you may have guessed, then there was no digital fabrication in the school at the time I was in school. So we didn't. I mean, I think it's amazing how that sort of part of the kind of narrative arch of architecture has reconnected people with the interest in material and craft. Because I think that, you know, during the sort of 80s and 90s and early 2000s, that got lost in a bunch of like really theoretical exercises. And so the people with more recent education have had that, it seems, at least to me, in many cases sort of served up as a fully valid kind of interest, right, in school. Be interested in materials and how materials are processed and made into things, and even like yourself, go off and be like an expert in actual fabrication, right? So I think as a conclusion to that, you know, every time someone presented me with some weird computer program that would quote unquote like make designing easier, I jumped on it. Never did very good designs, and I realized eventually that I'm just not a very good architect, and I'm okay with that. You know, I'm fine with someone else coming up with the thing, and then I help them figure it out. But that took 12 years of my life before I admitted that to myself. But once I did that, everything was good. And I think, you know, the architecture education teaches you that problems are not linear. There's a solution space. And I think that is valuable everywhere, regardless of what you do.
Yeah, solution space. Surely one likes that. Carl, how about you?
Yeah, I was thinking about it. It's a great question, Zuby. I think it's, I was trying to reflect on it. I think I was probably like grew up in my family's fabrication shop, and I was using a computer probably when I was like 13, 14 years old, but it was a CNC knife cutter to cut vinyl for graphics, right? And so I was never using a computer. I was always using this thing that was for manufacturing. And even in like Gustav, in when I was an undergrad, there was no digital fabrication. Even when I was in grad school, there was just the start of digital fabrication. But I think to answer your specific question, like why start looking at kind of computational aspects, it was so that I could talk to the machines, right? And I think like Gustav said, it's like, yeah, you know, and I'm sure we're going to offend people when we say this, but like I could draw a sketch somewhere, but that can't talk to the machine. And so if I want to cut something, if I want to print something, if I want to render something, if I want to bounce photons off of that thing, if I want to test if it can stand structurally, like I have to get that into the computer, because the computer was that kind of translator for me to make, you know, to lift something with a robot, to do anything, right? And to the realization that the precision with which you could put it into the computer to then translate it with a precision to come out. And that was a thing that totally changed it. And I think has, you know, I was also thinking, I don't think I've ever taken a programming class, right? Or a computational design class. I think everything, learned CATIA on my own, attended a workshop, right? Learned Grasshopper on my own, learned Rhino on my own, and was quickly teaching those things. And so I think it's harder for me to wrap my head around your questions, like what would I want to have been taught in school? Which I think I'm tasked with to some extent, but it's not about my own retroactive understanding about these things, but it's much more about seeing that, I don't know, and maybe it's a mix between, certainly in the professional world, it's the investment of time that pushes us to never build a physical model, but to model the thing digitally, right? Because you can do all of those things. But then I think intellectually and creatively, there's all the other things that we can use these tools for as well. So for me, it makes a lot of sense to be starting to learn those at a foundational level. And amazing to me, there's an incredible rich history in terms of computer science and algorithms and who was thinking about these things and how they played out. And so I'm trying to incorporate more and more of that into my classes, right? That there are these historic people that came before that were struggling with these issues.
Yeah. So speaking of your classes, and what Gustav said about having recognized what he isn't good at and what he's good at, there's definitely a increased degree of specialization, like in the industry now, because of the introduction of some of these computational tools and workflows. So how would you say academia is preparing students for this specialization that's happening in the industry? Yeah.
It's also a really good question. And maybe, I mean, I can't speak to all of academia because, but I would actually point to you guys. Like, I love supporting what you guys are doing because it points to something different. Like I'm critical of education of architecture because from an accreditation process, it treats everyone the same.
Okay.
Everyone is supposed to become the lead designer, right? And we all know, everyone that's attending tonight, everyone that's in the industry is, and you know, even in the way that Gustav talked about it, is like the specialization between, I love your term, spaghetti monsters, people that make spaghetti monsters and people that like type in the code. Those are two different people, right? And so I think education is still struggling with a very antiquated notion of educating everyone the same. But at the same time, we also believe that like a really good architect should be well-rounded and be able to engage all these things. And so it's like, how do you balance? There's only, you know, we can't keep adding more and more years to make someone that's both well-rounded and specialized. And so how do we, you know, we have to find that balance. And it feels like we're almost at that breaking point where we might have to soon give up on the general architecture education for, like, I don't know, I was looking at Gustav's CV, like so many schools, right? I think I have 7 years of architecture education, right? And so it's like, how many years do you need to become an architect to then be able to specialize, to then be able to do something else too? And so we might be at that breaking point soon, which will be an exciting moment. But and also, like Gustav mentioned, is like, I hadn't really thought about it this way, but how quickly digital fabrication has kind of come on the scene, right? And in some ways, like, cracked open that aspect. And so when you insert digital fabrication into a curriculum, what drops out, right? Something has to drop out because it's a finite period of time. So we'll see. It feels like we're not quite there yet, but something has to come soon, or something has to break soon.
Yeah.
Yeah, I'd actually be curious. I know, Zubi, I know it's you asking the questions here, but I'll just I'll just butt in a little bit. Molly, I'd be curious. I mean, not to put you on the spot, but I'd be curious to know what would you have done if not this that you do now, given that this is not the obvious path for an architecture degree holder.
That's a difficult question, because if you asked me, you know, before I went to architecture school, I definitely would have chosen a super different path than this. I never imagined that I would be the kind of, I guess not architect, but like architecture industry person that is like working on a computer all the time. So it's really hard to say, but you know, to what Carl is saying, perhaps I slightly misrepresented like my education. I know that, like, for me, I took a really specialized interest in digital fabrication methods. And at least when I was in school, the digital fabrication classes were still electives. They were not, you know, integrated parts of the curriculum. So it was like it was a choice for me to go into that. And I was sort of like guided into that by like mentors that I had at school. And so it is hard for me to say where I would have ended up, because I like started in digital fabrication in my like second year of school. So it was it's hard to know where I would have been because like I said earlier, like it's not like we called this computational design when I was in school either. Like for me, I'm just seeing it as like the next logical step of like the next logical tool that's going to be widely used, the same way that, like, you know, Frank Gehry popularized BIM modeling, and like, you know, how like AutoCAD and stuff became an industry standard tool, and like how now Rhino is now almost an industry standard tool to be using. So I don't know. I think the kind of architect or designer I thought I was going to be definitely just like wouldn't have existed by the time I got to this point in my career. So
Okay, that's a great answer.
I agree. Yeah. I'm gonna Gustav and Molly, I'm gonna put you two against each other now. So you talked about rationalizing geometry, and I know Molly, on the Providence Bridge, you you were very instrumental in helping to make sure like the double curve panels were buildable. Like, so there was some rationalizing that you had to do. Now, Gustav, you are not a fabricator or that sort, but you had to deal with the rationalizing of the model as you showed. Who's responsible for rationalizing the model? Like, Gustav, are you taking market share from situ fabrication, or who's responsible for what? Or should the architect be responsible for it as well?
Molly, do you want me to start? Okay. So I think there's a two-part answer to that question. One just because the specific case of the Providence Bridge, which by the way, I was able to visit a few months ago, and guys, great job. That was it's again like wonderfully designed and functional public space and a beautiful object. So really well done. But in the specific case of that project, I think that the value that I feel that we added as the engineering consultant, and this is before my life at Wolpe Moore, I should say, it's not the Wolpe Moore we, is my former employer. But all the same, the value that can be added really by any engineering consultant is to be educated about what someone like Situ might want to do and might think is important versus not so important. Like, you typically, an example, for instance, like it's most of the time, it's not worth it to curve primary structural steel if you can curve secondary steel, for instance, or if you can do a mess of light gauge or something that no one's going to see. And as an engineer, designing the kind of interface there that that some advanced fabrication system is going to clip into, to know that and to be able to speak intelligently to that so that the money is not put in the wrong place, so to speak, I think is incredibly important. It is, except for when we do fabrication modeling for steel fabrication, like using Tekla to do the full kind of modeling down to what gets actually sent to mill order. In my experience, it's never been useful to second guess experts like Situ or others, but only to sort of lay a reasonable groundwork for them and be reasonably educated about, again, what matters to a fabricator, right? And then let them take over. So I think that the overlapping slice of the Venn diagram in terms of market share is very thin. In terms of knowledge sharing, I think it's pretty wide, but only in a useful way. And in fact, we love when we get to work on design assist projects, so that contractors and fabricators come on early on, and you get to figure things out together. Unfortunately, because of the way that human psychology works, that always seems to be more expensive to most clients, and therefore they don't want to do it and end up spending more in the end. But what are we if not creatures of habit, right? So.
But maybe, Gustav, one question to follow up on that. You talked about the market share of those things. And do you mean market share of quantity of time or market share of value? Because those two things may be very different, right? And the value that the rationalization could bring. And you had one diagram that you flashed, and I wasn't sure what one of the numbers was, but it went from like 4 inches to like 10 feet, but it was the square footage implications of the overall facade. And I was just imagining, like, trying to do some math, like if it's 100,000 square feet, like the difference in that decision is millions of dollars potentially, right?
Precisely. And I can't say if that's true for the specific case of the Providence Bridge, just because I don't remember the square footage or the per square foot cost of cladding or whatever. But in principle, it holds true what you're saying, Carl. That if you can be smart about your detailing and your assembly logic, so that you offset everything back, for instance, if the goal is to minimize square footage, right? Then that quickly becomes very meaningful. And again, like the market share, like Situ situ are always just going to be better than any engineering consultant at what they do, right? So there's absolutely no point in competing in that space. But there is a big point in getting on projects, collaborating in a way so that we learn enough about each other's ways. And I mean, this is a two-way street, Molly. I'm sure you can speak to this as well, right? That it's good for you to know what typically gets put in front of you in terms of a bid document, which I'm sure half of the time you want to pull your hair out, right? Because there's so many things that are not defined properly and that you then have to figure out or price with a contingency because you don't know what is intended and whatever. So whatever can be like, tightened up, so to speak, by the design team, consultant team, regardless of who's going to make it, is, I only see it as being sort of, to use a very little bit of a tired term, like it's synergetic, right? It's not competitive, but it leads to just more than the sum of its parts, basically.
Yeah, I guess I could jump in and if we go back to Zuby's original question about whether it's like whose role it is to rationalize geometry and stuff, like I think what Gustav is saying about it being sort of more of a, like, yes, I also really enjoy design assist projects as well, because it allows us to have, a little bit more input, and it allows us to sort of gauge what types of geometries the designer is willing to compromise on, and so with the bridge, for example, for those of you who don't know, Situ's role on the bridge was just for the wood fascia cladding panels that are on the outside of the bridge. And for that, of course, besides, obvious budgetary concerns, the wood that was chosen is a really, really hard wood. And so there are material limitations as well for what can be accomplished as far as like curving it. And so there are a lot of, there was a lot of it that was just sort of straightened out. And, it was great working with Zuby and Inform to determine like what parts are allowed to be a little bit straighter and broken up into these straightened sections. So yeah, I don't know. Was there another part to the question? I forgot.
It was who's responsible for that rationalization? Like, is it everyone, or does it just have to get done?
I mean, I would like to say that it's a collaborative. It's everybody's, because we do ultimately want the designer to have their part of the vision realized as well, and like we want to do everything we can to help realize it. And so, sometimes if that means spending some extra money to be able to steam bend wood that doesn't want to be bent, or in our case, we were really lucky to work with somebody who had a lot of experience in fabricating boats. And boats have a lot of curved geometries all around. And so our subcontractor for the Providence Bridge was able to like manipulate the wood in a way and he curved the back of it so that it would bend, which was really amazing to see. And that was something that, without his expertise, him and his firm's expertise in boat building, we would not have been able to accomplish. So it's a lot of, knowing what the material can do, knowing what your engineers and what your like subcontractors and people who are working and actually fabricating the project are able to do. And, being able to communicate some of the limitations back to the designers so that everybody is on the same page.
Fantastic. Going to the audience now, question came in. In discussing new digital drawing and fabrication tools that is increasingly being used for design, as architects, we still must communicate this to clients and contractors to get built. Gustav brought it up that a parallel path of 2D and 3D methods should be followed to communicate design today. Can the panel chime in on how they would take action to change the local building department in accepting digital information, 2D, 3D, that communicates design intent to get a permit to build? Who wants to go for that one?
I'm still stuck. I like Gustav's point, which made me, I don't know, I'm thinking much more about this. And I'm going to use it much more, but you made a distinction. Actually, you didn't, I think you didn't make enough of a distinction, but you talked about rationalizing versus dumbing down. And it just started to make me think more about these two things. And I wonder if almost rationalization, right, to maybe unpack that a little bit, rationalization seems much more in the design aspect, and possibly dumbing down, because you also brought up the aspect of permit drawings and other types of things. And I wonder if almost dumbing down and looking at some of the drawings that you produced is like all of that data is embedded within the model, but then there's a little bit of data that's extracted and put into a drawing, right? Which is kind of static and frozen and ready. And then I wonder if there's an aspect of that too, because having worked with building departments, you know, they have no idea really what's going on in some of these projects. And so maybe the dumbing down is some aspect of just extracting just enough information to articulate just what they need to know, versus all of the kind of embedded intelligence within something else. In terms of like rationalization, I'm thinking of like the Sydney Opera Hall, right? Like there's not, that wasn't dumbed down, it was rationalized. And I see a lot of that discussion tonight. And so, but it's absolutely, that's the limiting factor, seems to be the building department. But I also wonder in the end, like the work that Gustav showed tonight, like all the liability is with the designers and with the fabricators and with the contractors, not with the building department. So, you know, why is all of this being driven by what they need to see or what they need to know?
I think that really borders on a very big discussion of another sort. But I mean, it's also difficult. I mean, you know, I am as I guess are you, Molly, in the New York City metro jurisdiction, whereas the rest of you, or you know, at least the organizers here, and I think you as well, Carl, you're in the sort of Detroit metro area, right? So, you know, it's a lot of local. It's a lot of local culture in a way, in my experience, where you can work with this in a meaningful way. So let's take, like, as a parallel example, something that comes up over and over again when you're an enclosure consultant, it's fire, right? Both assembly level combustibility or flame spread and that sort of stuff, and also the individual materials or the propensity to catch fire. And there are rules, of course, and there are code provisions, and then there are code officials that can still just say, well, that may be, but I don't like it. I don't feel comfortable. And they have that absolute authority because they are supposedly the last kind of, you know, bastion between some, you know, some crackpot building scheme and a horrible fire that kills people. And so the way to work with that is by precedent, right? You show them, but hey, look at this thing that worked. And at that point, the delivery method is like off the table completely. Like you have bypassed that, and you're basically like, this is. I don't want to call it politics because, you know, last year and everything, but it is in a way a political exercise, right? That you're navigating in that way, and in a way, I don't think that in the case of the product I showed, I'm mentioning this because in the case of the product I showed, I don't think at any point that it was the what's it called, the authority side of it that was really the problem, right? The authorities were not the bottleneck. The bottleneck was a contractual framework that we have not yet figured out between the different private entities that are, or, you know, private, public, whatever it may be, but like the stakeholders. And in the case of complicated projects, complex geometry, whatever it may be, like, you know, most of the time it can go through authority review because they don't really know what they're looking at, right? And so you can only hope that you did it right, and that your engineer and architect of record know what they're doing, which they do, of course, because they're educated, licensed professionals, right? But to sort of tie back, like I don't personally think that the documentation deliverable ecosystem has really actually very little to do with the permitting process at the end of it. Like if we figured out, I strongly feel that if we figured out inside of our industry from the early stage design down to fabrication and contracting construction, how to exchange information in a sensible way, I think the rest would follow. And we're not there yet, but we can get there.
I guess, Molly, what's your take on the permitting for, like, what kind of experience has you had with that?
At least in my experience at Situ, we generally don't need permits for any of the things that we construct. We are usually like Finnish subcontractors. The scale of a lot of our projects are very small. So like even to get back, if we could circle back for a second to the question of rationalization, a lot of the things that we do don't even need to be rationalized from like not in the same way that Carl's talking about rationalization is dumbing down, but like in terms of rationalizing geometry into something that is understandable to build. Like we don't even necessarily have to do a lot of that, just because the scale of things that we do is often able to fit on, our 5-axis CNC machine. And like, you can just put the geometry in and it'll do exactly what you tell it to do, right? So the scale of stuff that I have worked on at Situ I've never touched a permit application. So, it's hard for me to say exactly like, what that would mean. I do know that for Providence, we did deliver a lot of our drawings in 3D model form to our subcontractor who fabricated the panels. And so like, that was something that they preferred for us to do. And so I think it really comes down more to what your construction team is comfortable doing. Like in our shop, we will still give 2D drawings because sometimes it's just a lot easier and quicker to refer off of a 2D set than to like go back and forth between, your real physical space and a virtual 3D space. So I think it depends a lot, but I don't have any answers as far as building permits go.
So switching gears from issues with the permitting officials to within the industry, will you say there is a disconnect between the design end of things and the construction end of things? Is there a gap in terms of one group being able to speak the language of the other group to properly execute a project? Anybody can answer that.
I'd say there's often a disconnect, not only in those things, but also in motivation, right? I think as architects and designers, we might want to be pushing innovation in terms of form or space or whatever it might be, or innovative material. And I think many contractors, one, have a huge risk on a project and carry a lot of liability. And I think innovation they might want to see is how to do the project faster. Right. And so it's just and sometimes it's just a misalignment of even just at the most basic level of motivation. What would be a successful project? We don't even necessarily agree on what those things are.
Yeah, that's a really good point, actually. And that, I mean, at the extreme, if you don't subscribe to the same sort of set of parameters or, version of reality in some cases, then it might be hard to agree on anything, right? Or even just like have a baseline for what needs to be done. I remember I visited years ago. I went to see a great talk from a woman. I believe her name is Suzanne. Her last name is Anker. So she heads the at the time at least headed the Department of Bio Art at School of Visual Arts here in New York, I think it is. Which it's about like fusing biological sciences with art, and was asked inevitably, at the Q&A whether what she did was science or whether it was art, and she answered that, art is novelty and science is repetition. So those things can never actually meet.
Oh.
And I thought in that moment that that's kind of, sure, yeah, I mean, it's a little bit of a slogan, right? But it really, for me, it summarized a lot by why I was so like, I was like a deer in headlight as an architecture student, and after too, like at the enormity, of all of the things that you have to do. Just the task in front of you is just like so monumental, right? And at the same time, you're trying to innovate, and everything should be like the first of its kind, and this and the other. And as for me, at least, the most valuable maybe sign of experience, I guess, of actually learning something as you go along, is where do you focus on that innovation, and where is it? I'm not going to say pointless, but where is it misdirected energy to try and be novel, right? And the better I think you can strike that balance, the better of a practitioner you aspire to be in principle. And I think that is I can't speak for all educational systems, of course, and institutions, but I feel that balance is not struck in schools, but it's not really recognized that is a thing, and I think it should be a thing.
Someone says, this is interesting. Carl, why do we go to college? Most of the things we learn are on our own, or you have met the right people that pushed you to where you are now. And I'll bet that you learn everything outside of school, which is just trying to make connections and be innovative.
Well, that's a super interesting thing. And maybe all the answers are in the question, right? So maybe, yeah, I think we learn how to learn in school, maybe, or one could argue that we learn how to learn, and it gives us a certain discipline. There's certainly, not to get into too much higher ed discussion, but there's certainly a discussion that going to college is also learning how to be an adult, right? The first time away from home, in a protected environment, on a campus, learning how to do laundry, learning how to wake up, learning when you should go to sleep. Like, we learn all those things as an undergraduate in school. But I would also say it is that network. It is even Molly was really funny in that we were trading messages before, but she had a faculty member that I know, right? And so it puts you in a kind of context. And I worry sometimes, and I love the question. This anonymous person is so on tonight with so many great questions. But learning in a vacuum can also be incredibly dangerous. So yeah, we can pick up some things on YouTube, we can do some other things, but I think it is maybe learning how to learn, putting things in a kind of context, learning how to frame them, a discipline for that, and building your community. I think I think someone once told me, is like, I forget what the order was, like, go to undergrad and meet your spouse, and go to grad school and meet your future business partner, or something like that, right? Like, there's that network of people that you learn when you're in school is incredibly important. And so maybe it is just, there are other things. And I don't know, I leave answering that question wondering, like, yeah, how important is the curriculum versus what all those other things are that get delivered with education, especially when we're talking about the computational design that we're talking about tonight. Like Molly said, that was an elective for her. There are often electives, and maybe those are the most interesting moments that give you a kind of launch pad, because I love what Molly's doing. I love that she's in that role. I love that she was educated as an architect, and none of these things would be possible without those electives.
Yeah. So going back to what you said about the idea of extracting information, there's a question here. Could there be a different way to get the right information in the right hands? And to that, I'll also ask, what do you all think the deliverable of the future is? So,
I'm happy to jump in first.
Yeah, go ahead.
I mean, I feel like this is very far into the future because it will take a lot of learning. But I was reading an article not too long ago about some brickwork that was being laid in VR. I'm sure that you all saw it. I think it was like an article on Arc Daily, and like, you know, being able, and I think there's like several other projects that I feel like I must have heard about where people are projecting, you know, 3D models into physical space, and doing all sorts of augmented reality type of things. And I think that's really cool. I don't know how possible it is, because I think it would require like a lot of people to learn how to be comfortable in a virtual or augmented reality space, which I feel, you know, sort of gets into uncanny valley territory, where some people are just simply not going to be comfortable with that sort of thing. But I, at the same time, like with what I see in Situ's shop every day, like there are just some things that are easier on paper, and there's, you know, perhaps that is because of our education, and that we're all trained to read things that are 2D on paper. Of course, not everybody knows how to read drawings, but you know, it's really hard to say. It is always going to be my answer, I think, because we don't know. I feel like there's always a lot of technologies that are under development that we don't know about, especially in the architecture industry. And there are a lot of technologies that are sort of existent in other industries we don't know about, that then get brought into ours. And so unless we're going to, as an entire industry, be more proactive about finding new technologies and learning new ways to build, then I don't know how easy or difficult it's going to be to break away from 2D drawings.
I want to agree with you to a degree there, and also, or rather, no, I agree, but I think that maybe the reason for that is different, because you know, I think that we have, as we digitized our world and our lives, you know, during some of you have don't maybe not really seen any other reality than that, but there was one, and it was non-digital, and it was okay, but there was a lot of things that were incredibly difficult, you know, like finding your way, calling a friend, this and that and the other. And now maybe some of them are overly easy and not necessarily to anyone's advantage, but it's there, right? And we're coping with the technology. But I think a thing that has gotten lost or been grossly kind of underestimated by you know, whoever has had a stake in kind of introducing more and more digital technology in people's life, is that there's a kind of a basic tactile need that we have and that we like, because we're sort of pretty simple beings in the end, in many cases, right? I got thinking about this because I don't know if anyone else has done this too during, you know, we're also original during this past year lockdown, right? So once I had wasted a bunch of flour on failed sourdoughs and I didn't even want to go with the kombucha, I got interested in printing photos, you know, which I haven't done for I don't know how long. Like I literally think I didn't have before this year a single photo on a hard copy that hadn't been from the time that when negatives were, you know, developed into hard copies, right? And it's completely pointless, right? You take your digital photo, you have the freaking thing on your phone or your computer, and you look at it like that. It's a perfect closed ecosystem, and yet it sucks. Like I hate looking at pictures on a screen. So I print them and I frame them and I put them on the wall, and it's like super old hat. But it's not like, you know, this nostalgic. I feel that it's not just this nostalgic kind of irrational thing. Like it's actually like it's a tactile connection that you have with the thing that actually makes it mean something other than what it would have done when it was flashing past on the screen. And I have started thinking that it's the same with drawings, whether you are like in love with the act of hand drawing and you think that's like a really sort of, you know, beautiful thing that connects you in a certain direct way to the drawing, or you just like the sense of paper under your fingers. It's like something that we disregarded it, I think, for a long time, thinking it was primitive and we should do away with it, and maybe it's not quite that simple, and maybe ultimately, you know, I think it's okay. You know, I have a smartphone and I have a vinyl record collection, and I think both of those things are okay. you know, it's the most inefficient way ever, except for maybe like, you know, 8-inch tapes to listen to music, but I'm good with that. There's a ritual. And so both things can be true at the same time, right? And I've started to wonder, even though I made that kind of little bit polemic statement at the end of the talk of like, you know, we need to move into another type of environment, I actually think that maybe there is a hybrid that, you know, caters to both our need for efficiency and kind of global collaboration and all that, but also just like our more primitive needs for like holding stuff in our hands. I think that could be okay too if that was true.
That was a huge thing for me with 3D printing, right? For the longest time, I hated 3D printing because there was no, like in the same way that we've been talking about rationalization, there's no translation that occurs. You press a button and it prints, but at a very, very small cost. Like if you think about the studio space in a school, when everyone closes their laptop, there's no more work anywhere. And so for a couple dollars, you can print out something and at least you can have something in your hand that was some form of output that's tangible from that virtual thing that you've been working on. And so like, then there starts to be stuff in the studio, right? Things that are just those kind of leftover artifacts. Otherwise, you're right. It's like, I'm always talking about photos on phones, but how many do we have? And we never look at them again, right? I have 6,000 photos on my phone, but I'm never going to look at them. You can't appreciate them. They're not, you know, like when we switch between digital and physical, one goes away. And so how do we get a kind of both the kind of simultaneity or the notion of the digital twin, but also like, you know, I don't know, somehow my house is still messy, right? Even though there's not, now I have like a digital mess in one place and a physical mess in another place, and those aren't even the same things. So like, how do we start to get those things to come out of the computer? Like I want them to persist in the studio space or in the school space.
Yeah, and it's a really useful troubleshooting exercise too, because, you know, at least for most of us, the end game is something physical, right? In the physical world that we are with our physical selves going to interact with, occupy or touch or, you know, sit on or whatever it is, right? So, and it's not going to get done right the first time. So if you dwell on that kind of digital world like for too long, and then like you do, oh, finally press print, you know, and then it goes wrong and it's too late and like everything is just half-assed. So I think that if nothing else, just to like fail, you know, not to sound like super Silicon Valley, but like, you know, fail earlier and fail often, right, has a certain value in that regard too, that you just prototype, because sooner or later, if it's going to become physical, it's better to maybe do that earlier. And like in, you know, we're merchants of physical stuff in the end, most of us. So the fact that it should all be digital until like the 11th hour is in a way kind of maybe not so intuitive in the end, now that we've tried that for 20 years. So I think the hybrid model is the way to go. Individually, probably tailored to each kind of practice or project or what it is, right? There's no single answer to it.
It's 2 minutes past 8 now, and I want to respect everyone's time. This has been an incredible event. Thank you to our panelists, Carl, Molly, Gustav. Thank you so much for filling us with so much knowledge. And there are tons of questions here that unfortunately we can't get to, but fortunately you can join us on Discord with those questions, and then we'll get them answered, or at least start a conversation. And you will find this recording on our YouTube channel. So check back, and yeah, look forward to the next event. Thank you all for joining us. Bye.
Thank you, guys.
Thank you so
Nice
much.
to meet you. Thanks for the conversation.